Okay, so for the first question, if you get a remainder of 0, what can you conclude? That the binomial is a factor of the polynomial. So they said if you take a polynomial and you divide it by a binomial and you get something with a remainder of 0, then what can you say? Well, you can say that the binomial is a factor of the polynomial. And then for number 2, if you take a degree n divided by a degree 1, well, you're going to get the result. So if you have a polynomial of degree n divided by a binomial of degree 1, the result will be a polynomial of degree n minus 1. Then, so we did 1 and 2. Let's look at 5. So 5, it wants us to use long division. So let's rock it out. I'm going to get a new page to do that, if that's okay. So here for number 5, it says 3x squared plus 32x, 23. So 3x squared plus 23x plus 14 divided by x plus 7. Well, 3x would give us 3x squared, and then plus 21x, and we want to make sure and use these parentheses. They are so very important. So you're going to get 2x, bring down the 14, and you want to multiply by 2 to get rid of the 2x, 14, and I think you'll see that you get a 0. So x plus 7 is a factor of 3x squared plus 23x plus 14 because it divides evenly. So that was number 5. I think we now need to do 10. C. If I look at 10, I've got x cubed minus 126. I want to take that and divide that evenly into x minus 5 size pieces. Well, the first thing you'll notice is that we are missing 2 placeholders. We have no x squareds and no x's. If you do not put those there, you will make some mistakes. So in this case, I guess x squared gives us the x cubed minus 5x squared. These subtract and give you, this is 0 minus a negative, so that's the same as plus 5x squared. Bring down the 0 x's. So I guess I need my plus 5x to give me 5x squared. This times this is minus 25x. Subtract. It's going to be 25x minus 126. So I think we're going to have to do plus 25. So it's going to give me my 25x minus, that's going to be 125. So then if you subtract, you're going to get a negative 1, remainder of negative 1. So that's telling you that this divided into this size pieces gives you x squared plus 5x plus 25. There's negative 1 left over, and we divide that into x minus 5 parts. So you can take this thing and rewrite it as a polynomial minus a little bit, which is so helpful. For that first one, it was you can take this and divide it into this many pieces, you get exactly 3x plus 2. And those are exactly equal as long as x is never negative 7. You can replace one with the other. So that's 10. I guess we now need 19 and 20. 19 and 20. So for 19, you get 3x cubed minus 2x squared plus x minus 4. Let's divide that by x plus 3. Do I need any placeholders? No. So this is this, gives me some of this, plus 3x, no, 3 times 3 is 9x squared. Make sure you subtract. Minus this is minus 11x squared. Bring down the x, so I do minus 11x minus 33x minus 33x. So this minus a negative is 34x, what, minus 4? So plus 34 gives me 34x plus 102. So you subtract, you get negative 106, right? My remainder is negative 106. Just going to double check that because that feels weird. Just in case. That was number 19. My internet is slow. 19. Yep, I was right. And so why is that great? That means that 3x cubed minus 2x squared plus x minus 4 cut into x plus 3 pieces is just this thing. And the remainder is negative 106, and we divide that into x plus 3 pieces. So what it's saying is that ugly rational expression can be rewritten as a polynomial minus a little bit. Isn't that so cool? I think that's really cool. So that's 19. I think we can now do 20. So now when you look at 20, let me go back. When you look at 20, it should be negative 6x cubed plus x squared minus 4 divided into 2x minus 3 pieces. So when you do that, notice you need plus no x's. So I guess I'm going to do a 3x squared to get a negative 3x squared to get negative 6x cubed plus 9x squared. This minus this is negative 8x squared. Bring down the no x's. Negative 4x gives me negative 8x squared plus 12x. This minus is going to be negative 12x minus 4. So I guess I'm going to do what? Minus 12 is minus 6. So minus 6 is minus 12x plus 18. So this minus a negative would be minus 32 is our remainder. So if you take this and divide it into this size pieces, then everybody gets this much, with negative 32 left over that we cut that among everybody, right? And so this can be rewritten as a polynomial minus a little bit anytime you want to, which is so cool. So we did 20, we now need 39, 45, and 47. So 39. So 39, it says, is this a factor of this? And if so, write out its factorization. Well, to be a factor, we need a remainder of 0. So we're actually going to do the division. So we put in our placeholder that we were missing. And I guess I need 3x cubed, gives me 3x to the 4th minus 6x cubed. And when you subtract, you get 0. So then you pull down the 0x squared, and that doesn't help. So then I guess I need to pull down 2 terms. So I bring down this and this because it wants to attack 2 terms. So I go negative 5, and that gives us negative 5x plus 10. So when I subtract, I get 0, remainder of 0. So, remainder of 0 means, yes, it is a factor. And specifically, you can write that this, when you divide it into this size pieces, well, this times this gets you what you had. That's the factorization. And that is number 39. And just to make sure, it's 45 and 47, right? Yes. 45 and 47. Let's look at 45. 45, it says use the graph and one factor to write the factored form suggested by the graph. Okay, so this is the leading coefficient is 1, it says. Okay, so if we're looking at 45, let me show you the picture that it's talking about. Okay, so for 45, it says we've got this sort of a situation. Let me hit crop, boom, 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 boom. Okay, so if that is what we've got going on, we know that since we have a 0 here at 1, so x equals 1 is a 0, means that x minus 1 is a factor. So since x minus 1 is a factor, and this looks like, because it goes down, up, I think that we can write x minus 1. Let me see. Oh, we could divide it by x minus 1 to find out what the other one is. What's it saying? Let me make sure. Use the graph of one factor to write the factored form of the polynomial. So yeah, I guess the factored form is just going to be x squared plus 2x plus 4 is the factored form, because that's going to be a cubic, because when you multiply those together, you're going to get your nice cubic, and there you go. So that's 45, and lastly, 47. So for 47, it's saying, look, you've got a cubic where it's saying that one factor of our, whoa, let's be careful. So for 45, did I do the right one? Yes. Okay, so it's below it. So 47, it is below it. Okay. So this time it's below it. It's not always the case. Use picture. Excuse me. Okay, so it's this, and this, and this. So when we look at this picture, one factor is x squared plus x plus 1. And then it looks like x equals 5 is a 0. And that implies that x minus 5 is a factor. So we got one factor up there that they gave us. The other one is x minus 5. So that would be our polynomial that's suggested by that graph. Especially if, so when you put in 0, notice when you put in 0, you get -5 like we wanted. So yeah, this goes through that. Cool. Awesome. Thanks.